Welcome to the DIY Honda Garage channel. The DTC P0098, which stands for IAT Sensor 2-circuit high voltage, signifies a detected fault in the intake air temperature, IAT Sensor 2 circuit, within the Honda Civic models from 2016 to 2021. This error could potentially impact the vehicle's engine performance and fuel efficiency, as the IAT sensor plays a critical role in measuring the temperature of the air entering the engine to optimize air-fuel mixture for combustion. The IAT sensor 2 is typically located near the intake manifold, connected to the engine control unit, ECU, or powertrain control module, PCM. An irregular voltage reading indicates an issue that may arise from wiring faults, failed components, or electronic malfunctions. Before diving into diagnostic procedures, it is important to refer to the overarching guidelines for troubleshooting to ensure a systematic approach to the problem. The IAT Sensor 2, involved in the DTC P0098, is crucial for determining the temperature of the incoming air, informing the engine control unit on the necessary adjustments for optimal fuel mixture. This sensor actively influences engine performance, allowing for more efficient combustion, enhanced fuel efficiency, and reduced emissions. Its typical location near the intake manifold ensures accurate temperature readings as air is drawn into the engine. This sensor is connected to the powertrain control module, PCM, via a 2-pin connector. If the voltage readings exceed the normal threshold of 4.92 volts, this indicates a high voltage scenario, thereby triggering the DTC P0098. Troubleshooting the IAT sensor can prevent further complications with the vehicle's performance. The DTC P0098 may stem from several root causes that warrant careful examination. First and foremost, the IAT Sensor 2 might have failed, leading to inaccurate voltage readings. Faulty wiring or connections, particularly in the circuit leading to the IAT sensor or the PCM, could also create a high voltage situation by introducing resistance or shorts in the circuit. In some cases, a malfunctioning PCM may misinterpret sensor inputs. Furthermore, loose or corroded electrical connections can contribute to erratic signals from the sensor, leading to inconsistent performance and improper voltage levels. Thus, a comprehensive check of the IAT sensor, the wiring harness, and the PCM is essential in diagnosing the issue effectively. When the DTC P0098 is triggered, several symptoms may become apparent to the driver. Most notably, the check engine light will illuminate on the dashboard, indicating that the vehicle's computer has detected a malfunction. This error can lead to poor engine performance, compromising acceleration and overall driving experience. Additionally, drivers may notice decreased fuel efficiency as the engine struggles to maintain optimal air-fuel mixture. Rough idling could also be experienced due to inconsistencies in the combustion process, resulting in an unstable engine state. Identifying these symptoms early can assist in timely repairs, preventing further damage and enhancing vehicle reliability. The first troubleshooting step for addressing DTC P0098 involves verifying the current operational status of the IAT Sensor 2. Start by turning the vehicle to the on mode without starting the engine. Utilizing the Honda Diagnostics System, HDS, measure the voltage value output from the IAT Sensor 2. The expected threshold is any value exceeding 4.92 volts. If the measured voltage aligns with this threshold, you confirm that the failure is consistent and proceed to the next step in the troubleshooting process. However, if the readings do not match, it indicates an intermittent failure, suggesting a need for further investigation into possible electrical connection issues at either the IAT sensor or the PCM. Therefore, checking for loose or corroded terminals is advisable before proceeding. In the second troubleshooting step, the objective is to determine where the fault lies, whether in the IAT sensor itself or other components. Begin by turning off the vehicle completely, ensuring all systems are deactivated. Disconnect the IAT Sensor 2's 2-pin connector to isolate it from the circuit. To simulate the sensor signal, connect terminals A and B using a jumper wire. Terminal A corresponds to IAT Sensor 2 2P connector number 1, while terminal B goes to IAT Sensor 2 2P connector number 2. Turning the vehicle back to the on mode allows for new measurements of the sensor signal through the HDS. Again, check if the voltage exceeds 4.92 volts. If it does, the next step is to proceed with further diagnostics. If not, the IAT sensor itself is likely defective and should be replaced. The third troubleshooting step necessitates a detailed examination of the wiring leading to the IAT sensor. Start by ensuring the vehicle is switched off completely. Then carefully remove the jumper wire previously used between terminals A and B of the IAT Sensor 2 connector. Reactivate the vehicle to the on mode once more and prepare to take voltage measurements between two specific test points. The first test point is the IAT Sensor 2 2P connector number 1, and the second is the body ground. With the sensor disconnected, it is vital to measure to see if the voltage reading hovers around the expected 5.0 volts under these conditions. Getting a positive confirmation here means that wiring integrity is intact, and further diagnosis is warranted to the next step. Conversely, if testing yields lower voltage, a deeper investigation into wiring pathways may be necessary. For the fourth troubleshooting step, checking for continuity in the SG2 line is crucial. Begin by ensuring the vehicle is turned off, allowing for a safe environment to carry out electrical tests. Next, using the HDS, jump the Safety Communication System (SCS) line, allowing for simulated conditions to test the electrical pathways. After waiting over a minute for the system to stabilize, disconnect the PCM connector E, which is an 80-pin assembly vital for managing engine data. Continuity must then be assessed between IAT Sensor 2 2P connector number 2 and PCM connector E number 78 under these conditions. If continuity is confirmed, the SG2 wire is functioning as intended, thus guiding you to check for additional service information related to the DTC P0098, or substituting with a known good PCM might be required. On the other hand, the absence of continuity indicates a break in the wire that must be repaired between the PCM and the IAT sensor. The last troubleshooting step also focuses on continuity, but within the ITA2 into line. Begin by ensuring the vehicle is powered down. Then repeat the process of jumping the SCS line via the HDS, maintaining the same conditions for accurate testing. Disconnect the PCM connector E once again to isolate it during testing. The focus now shifts to continuity between IAT Sensor 2, 2P connector number 1, and PCM connector E, number 55. Continuity testing under these conditions aids in verifying that the ITA2 into wire is intact. If continuity is present, it is likely safe to presume that no repair is needed here, but similar steps should be taken next. Reference service documentation for further directives, or consider replacing the PCM if testing shows discrepancies. Lack of continuity, however, signals an open circuit that requires immediate attention and repair. between the PCM and IAT Sensor 2 specifically. Upon addressing the issues indicated by DTC P0098, it is essential to carry out a final verification process to confirm that the repairs were effective. Begin by clearing any stored error codes from the PCM using the HDS, which resets the system's fault records and allows for accurate new data logging. Subsequently, perform a test drive of the vehicle to allow normal operational conditions and note whether the check engine light reappears. During this drive, monitor the IAT sensor readings using the HDS to ensure they consistently stay within the expected thresholds. Confirming that all readings appear normal and that no new fault codes emerge during this test drive will validate the repair work completed. If any anomalies arise, further inspection may be necessary to pinpoint unresolved issues. Preventive maintenance plays a crucial role in ensuring that the IAT sensor and related wiring remain functional and efficient. Regular inspections of the wiring harness leading to the IAT sensor can help identify early signs of wear, fraying, or corrosion that could lead to future issues such as DTC P0098. Additionally, routinely checking the connections at the IAT sensor and the PCM will prevent loose or corroded terminals from introducing faults into the circuit. Keeping abreast of software updates for the PCM can also enhance communication and response times for temperature-related data, thus supporting optimal performance of the engine. Establishing a maintenance schedule, which includes these checks, ensures the longevity of your vehicle's performance and can significantly reduce the likelihood of future DTC-related issues. In conclusion, understanding DTC P0098 and the role of the IAT Sensor 2 in the Honda Civic models from 2016 to 2021 is pivotal in maintaining vehicle performance and efficiency. This diagnostic trouble code signals high voltage issues, demanding prompt investigation and corrective action. Through systematic steps involving voltage measurements, continuity checks, and careful inspections, technicians can identify the root cause of this issue effectively. By ensuring connections are secure, wiring is intact, and components are functional, a successful repair can be achieved. Furthermore, adopting preventive maintenance practices ensures ongoing reliability and efficiency, mitigating potential future issues. The resolution of DTC P0098 not only enhances engine performance, but also contributes to the longevity of the vehicle overall. Please like and subscribe to the channel. See you next time.